Okay. So this is the study session for the midterm exam in CIT 247. I'm going to share my PowerPoint. Okay, can you all see the PowerPoint?
I see it, yeah.
Okay. So as I said, this is the midterm exam review. So let's check this next slide here. So here's an overview, or the best overview I can give. Midterm exam is comprehensive. According to or Professor Rana, he intends it to cover the contents from modules 1 to 7. So basically everything you've done from the beginning to now. He currently plans, from what I can tell, to include a test and a GNS assignment. Depending on if he has time, he may or may not. He didn't say this, but he may or may not. There's a possibility he may or may not do the GNS assignment. We'll have to see, but I would expect it just in case. So the test will include multiple short answer questions. In other words, there are ones where you have to provide a written response. It could be around 7. I'll warn you all. It could be around 7. Now, I made them. The 7 that I'm talking about, I made myself. So I'll give you a little hint right now. So if all of these are used by Dr. Rana, 2 of them will involve network topologies. So one, you'll be asked to write down the configurations or write down in paragraph form how you would configure something. It's similar to the one short answer question you had in the first test. Then there's a troubleshooting question. Basically, I give you a picture of a topology in 3 command line pictures, basically 3 terminal pictures. Your job is to identify problems. There's actually a problem per terminal. Your job is basically to write down what the problem is and discuss how you would fix it. You can either use commands or write in paragraph form how you would fix it. One question will involve subnetting. Basically, I'll give you a subnet and ask you to find multiple things on it, like finding the first usable address, the subnet ID, and so forth. And then the remaining short answer questions will just be basic general knowledge. Like one will have you compare to networking devices. Another will ask you to answer certain questions based on a network concept that is in this PowerPoint. Another will ask you to list steps in a process also listed in this PowerPoint. So those are, and the last one is basically an open-ended answer. You can pretty much write from your personal experience with it. So that's basically the extent of the short answer questions I made. Does anybody have any questions on those, or does that help?
No questions here.
Okay, that's good to know. So I hope that I hope that makes you all feel a little better about the short answer questions. They won't be too hard, and I will give one more tip. Length, I won't be picky on length. So long as your answer is comprehensive and answers the question, reasonably answers the question, I will give full credit. I won't expect a certain number of sentences or words or anything. Just whatever works, you can put it. Even if you can answer the question like a couple sentences, that's good enough for me. Because yeah, you probably already know this, but I'll be grading the exam. But let's go over some tips to prepare for the exam. So to prepare for the midterm exam, I recommend going through the quizzes from modules 1 to 7 and studying them. I would say memorize the questions and answers. I don't know if the questions will be reused ones, but I have a feeling there's a good chance they will. But don't quote me on that though. It's a possibility they won't. Another thing I recommend is going through the Canvas PowerPoints, and if you have the time, the lectures. Lectures can help you. Cunningham's, if you don't want to listen to them, there are my lectures, which go over which are used to explain some harder concepts, and and they take much less time to watch. I also recommend using this PowerPoint specifically to narrow down your focus on key aspects on the exam. So basically, this PowerPoint shows you general topics that will be covered on it or should be covered on it. You can use it to help you identify anything you're struggling with or don't completely understand. And then if you don't understand a certain concept, you can go to the appropriate module and watch lectures and read those PowerPoints. I also recommend a textbook if you have time as well. The textbook chapters are also helpful for topics you don't understand. Let me see, there was one other thing I wanted to say. Did I break up there?
Yeah, your audio cut out for a moment.
Okay. If you don't mind, I'd appreciate if you let me know that happens. So I'll just repeat that for everybody else that's watching. Um, let's start from here. So again, as I was saying, this PowerPoint, the purpose of this PowerPoint is to help you identify which topics you're strong with, like the ones you understand really well and the ones you don't. So basically, if you don't, my recommendation for a study strategy is to use this PowerPoint first, read entirely through it. If you don't understand something, go to the appropriate module and read the PowerPoints and watch any lectures you have time to watch, and even consult the textbook too to get a better understanding of those topics. There was one other recommendation I had. Maybe it'll come to me a little later. Oh, I remember now. So one other thing I would recommend is to go through your old lab assignments, especially like the commands and stuff. That could help you with certain questions in the exam, especially a certain one I talked about. And it can also help you for the GNS portion if there is one. Well, speaking of that, for the GNS portion, I would say again, read the instructions carefully, make sure you complete them all. The GNS portion is open book, so feel free to use my command guides. Also, I have to stress this very heavily. Please make sure you save your configurations. The copy RUST command is very important, and also the save command on the PCs. One recommendation I have is to re-download your lab after you submit it, and then test it. Run it in your VM. Make sure it works. If it doesn't, you can upload as many times as you want. I don't penalize for re-uploads on the exam. So anything you want me to explain further, or have any questions so far?
No questions here.
Okay, I'll move on then. So this is a very important topic as a little hint. Learning MAC addresses. So you want to make sure you understand these steps. So the way a switch learns MAC addresses. So a switch first receives a frame on one of its ports. It retrieves the source MAC address from the Ethernet header of the frame. The switch then searches the MAC address table for that MAC address. If the MAC address is not found, the switch adds the address and port pair to the table. So basically, it learns source MAC addresses. So basically, when a device is trying to communicate with another one, that source device sends the frame to the switch. The switch then checks that frame. It checks the source MAC address in it. It checks its table to see if it exists. If it does not, it then adds it, and then alongside that address, it adds the port of the PC that frame came from. So there's another process you need to be familiar with. It's how switches forward frames. So it's basically how switches send communications to other devices after receiving a frame. So the first step is a switch receives a frame on one of its ports. The switch extracts the destination MAC address from the Ethernet header. It looks up the destination MAC address in its table. The switch then forwards the frame to the port specified in its table, unless that port is the same port on which the frame was received. So in other words, the switch is not going to send back a frame that came from the source, which I don't know why that would even happen. Actually, that would be like a loopback address, I guess. But the switch is typically not going to do anything with that. But if no entry exists in the table for the MAC address, the switch then forwards the frame out all interfaces except the port it originated from. So to explain this process, so when a switch receives a frame and is trying to send that to a specific destination, it first takes a look at the destination MAC address from the Ethernet header. So it's important to realize that frames have a source MAC address and a destination MAC address. The source address, as the name implies, comes from the computer that sent the frame. And the destination MAC address is the address of the computer that the source computer wants to talk to. So if that MAC address is found in the switch's MAC address table, it'll send that frame to the destination. But if it's not found, it'll actually broadcast that frame to all the other computers in the network. And then the computer that owns that MAC address, or actually the IP address, when ARP occurs, it will respond. So I think I got a fourth participant here. Hi. Oh, hey, Ben. Excuse me. So anyway, let's now talk about some network devices. So before I begin, does anybody, I know I keep asking this, but does anybody have any questions right now? Like Ben, I know you just came here, so do you have any questions you'd like to ask? I guess not. Okay, I'll take that as a cue to move on. So now let's discuss network devices. So the first one we're going to talk about is hubs. So hubs are basically a very simple version of a switch. They're basically the predecessor. You could better say the predecessor to the switch. So basically, if you look in this diagram, what networks used to be, how networks used to be configured is with a 10 base 2 bus. So basically, it's like a big, I guess it's like a big cable, and it would basically connect all the devices to one another. Problem with this cable is that if there's a problem, if there's like a tear or a break anywhere, the entire network goes down. So hubs have that over the single bus. So a problem on one cable doesn't impact the entire network. So in this case of the 10 base 2 bus, if there's a problem with Larry, then Archie and Bob, all of them lose communication. But on a hub, I mean, Larry can do whatever he wants to his cable, but Bob and Archie will still be able to communicate with one another. So also, hubs allow for the creation of the star topology. So basically, it's like, so you have like the hub in the middle, and then you have all of the devices poking out like a star. So hubs are good for that, if you can call them good. Problem is there's many disadvantages of hubs. They only have one collision domain. So basically they allow for, so basically in a network like this, when two devices communicate at the same time, these communications can actually collide with one another and cause some serious delay. So also devices have shared bandwidth. So usually devices are supposed to only send data one at a time, but still collisions can happen. So also hubs are rather insecure because their broadcast can be seen by all hosts. And as shared in bandwidth implies, these things do not have good performance. There's an old saying, hubs are evil. They really are. You don't want to use these things in a network unless you absolutely have to. There's really no reason to use these things at all. But just to let you know, these are the only things you really need to know about hubs. They're not used in this course. They shouldn't be used in this course, and they shouldn't be used anywhere. At least not with stuff like in a network. So then there's bridges. Not a big focus on this class. We don't use them in GNS either, but basically they, as their name implies, they bridge LANs together, or basically they bridge, specifically they bridge collision domains together. So they actually divide networks into two collision domains. So you see this bridge here. So this hub here is a collision domain. and this hub is a collision domain. However, the bridge actually separates these two. Without the bridge, this would all be one collision domain. Should be noted that this is also one broadcast domain. This bridge does not divide broadcast domains. This is all one big LAN or broadcast domain. But again, hubs or bridges are not a big topic on this exam, so just make sure you remember this. They reduce collision domains. They do not add broadcast domains, just collision domains. Now, a switch, on the other hand, works basically like a collection of bridges. So each port, so instead of like having one bridge, you only have like two collision domains here. Switches can have a large number of ports, and each port be its own collision domain. So all you really need to know about that, I don't think we really test on this duplex stuff much, but just know that switches basically break up devices into multiple collision domains. Each port on a switch is its own collision domain. However, the switch as a whole, and also multiple switches connected together, make up one broadcast domain. So switches do not break up broadcast domains. The only exception to that rule is VLANs. So so I know I don't have a picture for them here, but routers basically are devices that do divide networks into multiple broadcast domains. So that's important to know. So each port on a router is not only its own LAN or broadcast domain, it's also its own subnet. So that's something to keep in mind for the exam. Speaking of collision and broadcast domains, let's now discuss them. So a collision domain is a set of devices whose frames can collide with one another. So as I just said, if you look at this picture here, the hub does not separate devices into collision domains. The hub is the only device that we talk about in this class that does not break networks into multiple collision domains. However, bridges, switches, and routers all break networks into multiple collision domains. That's very important for the exam. This is a very key topic right here. Collision domains or bridges, switches, and routers separate networks into multiple collision domains. Hubs do not. Then we have broadcast domains. So a broadcast domain is the set of devices for which, when one device sends a broadcast, all devices receive that broadcast. So routers, as I was just talking about, you see this device right here. Routers separate the network into multiple broadcast domains. Also, it should be noted that VLANs, which are set on switches, can also create multiple broadcast domains. So before we continue, does anybody have any questions about what I've discussed so far? Does everybody have a clear understanding on collision and broadcast domains?
No questions here, sir.
Sounds good. Okay. So so now we're going to discuss hardware features. Now, this is another important thing. You were already tested on some test one, I believe, but I noticed some of you didn't quite get it, or didn't quite answer it completely. So let's review it closely. So these are hardware features that are or are not present on the following devices. So we have hub, we have the switch, and we have the router. So hubs do actually provide greater cabling distances. So basically they support Ethernet cables that allow for higher cable distances. So switches, hubs, and routers, all three support this. Now, as we just discussed, however, multiple collision domains are not supported by hubs. Hubs actually really don't separate anything. One hub is a collision domain. However, switches and routers do break up devices into multiple collision domains. Now, as far as increasing bandwidth, hubs do not, but switches and routers do that. Switches and hubs allow for greater bandwidth. And finally, multiple broadcast domains are only supported by routers. We're not, for the question in the exam, if this question appears again, we're not considering VLANs. We're only considering the device as it is. So only routers break up networks into multiple broadcast domains. So let's discuss the switch memory types again. So there's RAM, which is the working storage. So basically, this is your running configuration mode. Basically, if you think about RAM, it's basically short-term editable memory. So basically, you can think of like a cache in RAM. So basically, this has like your routing table, your MAC address table. This is pretty much where it's stored. It's working storage. So in other words, it can change quickly. It can also be lost if it's not saved. But yeah, it's volatile. That's the main point of RAM. It's volatile and includes the active configuration file. This is basically the running configuration file. So ROM. So the ROM is the type of memory that stores the boot program that finds the Cisco iOS image and loads it into RAM. Now ROM is uneditable. I don't think it'll be tested on that. But just to let you know, you can't edit the ROM. Now flash, it basically just stores the iOS image. That's all you really need to know about it. The flash memory stores the switch's iOS image. And finally, the NVRAM. So it basically stores up the starting configuration file that is used when the switch is booted. Now, I'd say this is editable because when you save configurations, you change the startup configuration. So this is editable memory, but it is saved. It's something that's saved. You could have some example CLI switch CLI sessions. They may even reappear. Some of them from exam 1 and the quizzes could reappear. So excuse me. So if you all don't mind, I'd like some volunteers for these questions. So the first question I'm going to ask you, I'm going to give you all a minute to review this command session here, and then I'm going to ask you the following questions. So after you're done reviewing, I'd like you to answer this question. What is the password used? So with these configurations right now, what was the password used, or what is the password used to log in to enable mode?
Is that password let me in?
Very good. So why do you think that is? I just would like to hear your reasoning on that.
Sure, because both enable secret and enable password are used, but secret takes precedence.
That's exactly right. Excellent answer. So, what is the password to log into the console? So, log into console. So, basically, this is taking a console cable with your computer and plugging it into the switch directly through the console port.
Here, I'll help out. Is that password spam?
Very good. So, what's your reasoning for that one?
Sure, that one was configured in console configuration mode.
Very good. So, yes. So, that the key here is line console 0. Very good. So, what is the password for telnet?
That password is also spam.
Very good. So that's the only option left, so I'll say it. So line VTY. So basically that's for like Telnet and SSH. That's basically signing in over the internet. So yeah. So that's important. That's an important thing to keep in mind. So the console password and then the VTY password. That's basically for telnet. This is for plugging in directly to a console cable with your computer. So let me ask you all, what is the message displayed when logging in?
This is a switch.
Very good. So one thing I wanted to say, I noticed a lot of you in the exam, or some people in the exam for test one actually included like the hashtags or something. Now I actually counted wrong in the system, but I changed that. I'd like you to just let you all know, you only need to include the message itself. You don't need to include the characters that are next to the message. The quiz will actually count it wrong. I can fix it though. It's not a big deal, but that's just to let you all know that. I don't know if you all see your grade after you insert the exam or you exit the test one, but yeah, that's just to let you all know. So my next question is, how many telnet connections are configured?
15.
Close. It's actually 16. So it's counting from 0 to 15. So a number of people got that wrong in the exam. I want to stress that here. You need to count from 0 to a number, whatever this is. So basically, you take this number here and you add 1 to it. And that should be the number of telnet connections configured. So here's admittedly a bit of a trick question. So what is the password, any password, after rebooting this console, if this was everything that was entered and the switch was turned off?
There wouldn't be a password.
Very good. Why is that?
It wasn't saved to the start config.
Very good. So yeah, that's a trick question you could end up with in the exam. You probably already ended up, I think you already got that in test one, but just to let you know that could happen. You could get a very similar question again. So let's go over some switch command examples. Basically, I took these screenshots from last semester, and I would review on my own. But these are to help you review the show commands you may need for the GNS lab if there is one. You may also get some questions on it too. So it's helpful to keep to be aware of what these are and their differences. So let's look at show VLAN. So the show VLAN is basically when you want to check the VLANs, when you want to see which ones are created, which ones are enabled or disabled, and which ports are associated with each VLAN. So another command you can do is show VLAN brief. It'll basically only show the top of this or the first half of this these results. So like you won't see any of this stuff. I'm not really even sure what a lot of that stuff is. I don't think you really need to worry about this stuff. It's more of this stuff you're typically going to be after, like the VLAN name, the VLAN number, the name, and then the status and the ports configured with it. So show VLAN brief is what I recommend using. So another command is show MAC address to table. So basically this, as the name implies, lets you see the MAC address port pairs the switch has learned. Another command you can use is show MAC address dynamic. For our classes, it's basically going to be the same thing as showing show MAC address table. Now, in production networks, MAC addresses actually are manually configured. Believe it or not, you can actually manually configure a MAC address to a port, and basically that keeps like hackers and stuff from being able to use the port on the switch because their MAC address is different from what is saved on the computer. Granted, that doesn't stop the hacker from changing his or her MAC address on their computer, but typically that's one feature of MAC address tables. You can actually add static ones, and basically that will limit which computers can actually use that port. It's a pretty interesting feature. Unfortunately, it's not covered in this course. It could be covered in CIT 484. Which I'm actually going to be taking next semester, but yeah, we don't worry about that here. Here's some more switch command examples. So show interface switch port. Basically, if you want to know a bunch of details about a specific port, this is your command. So basically, it provides a bunch of important facts like the administrative mode and the operational mode. And this is especially important when you're working with trunking. Also, if you look at this here, it also shows the encapsulation mode. So these are very important for like when you're working with trunks. So also it shows the native VLAN. So source interface switch port is one of the best commands you can use for trunking. That's actually why I put it next to this command, show int trunk. So this is pretty obvious. It shows information about the trunks, like the encapsulation mode, which ports are set as trunks, and their status, and also native VLAN. It's a lot clearer than this, obviously, but both are important and they're both useful for their own right. Specifically, if you want to know the administrative and operational mode, you need to use show interface switch port. Does anybody have any questions right now? I guess no. One other thing I wanted to mention about show int trunk is that it's the only place you can find the allowed VLANs on a specific trunk. So each command has its own use. Obviously, most of us would probably just want to use show int trunk, but show interface switch port is very important if you want to see the operational administrative modes on a port. So here's some more commands. Show interface description and then show interface status. They're very similar to one another, but they each have their own purpose. So show interface description is the place where you want to, it's basically the command you want to type in when you need to find the line protocol statuses of each switch port. So basically you have your line status and your protocol status. Now, if you see this is where you get admin down / down. That basically means a port is manually configured to be disabled. If you see down, that means the port's just disabled for some reason, like maybe a bad cable or maybe the switch or the other device connected to this port is disabled. So also there's show interface status. This is specifically used to show VLANs. It'll show the VLANs assigned to a port. Shows duplex settings, speed, and type. Not stuff we really focus on this course, but there's also the status. So basically, the status command is basically a combination between the line protocol status. It's a simpler status protocol, but it's considerably, well, it's about as detailed, but it's important to be able to use both. Status codes. So there's also show IP interface brief. I don't show it here, I don't think. Let me see. Yeah, I don't show IP interface brief, but basically what that does, it shows the IP addresses configured on your switch ports, which I'm sure you've been using that command in your routing labs. But with that out of the way, let's now discuss VLANs. So the typical term for a LAN is that a LAN consists of all the hosts in a single broadcast domain. So if you see this picture here, without VLANs, all of these devices and this switch would be in one broadcast domain, one LAN. The words LAN and broadcast domain are pretty much synonymous. So, however, a VLAN is basically a virtual LAN, as the name implies. So, as I said, all ports on the switch belong to the same LAN when you do not configure VLANs. But when you do, a switch can support one broadcast domain per VLAN, and basically each port on a VLAN or switch can become its own VLAN in its own broadcast domain. But here we actually have multiple devices on the switch share the same VLAN. So basically, this can help improve it can help improve performance because it limits the range of, it limits how many devices receive a broadcast frames. And also it's good for security and also helps you name different devices. Like you can have or name different LANs, if you will. So basically you can have like a production network, and with one switch you can have like multiple, you can have a VLAN for like the research and development. You can have a LAN for let me see now, you can have like research and development, you can have sales and marketing, and then administrators. So, excuse me. So let's discuss subnets and VLANs. So this is a very important topic here. So in lab 3, you had multiple subnets you were working with, and you also were working with VLANs. You may have noticed that the devices the devices in the same VLAN were in the same subnet, but devices in different VLANs were in different subnets. That's by design. That's the way it works. So because VLANs are basically different LANs, if you will, or different broadcast domains, they have to be in different subnets. So just put simply, hosts in a single VLAN must be in the same IP subnet. But if they're in different VLANs, they must be in different IP subnets. But for hosts on two different VLANs or broadcast domains to communicate, a router is needed, even if the hosts are plugged into the same switch. So, however, there is the option of multi-layer switches, but we don't really work with those in this course. So if you've seen, excuse me a minute. So now we can, however, VLANs can span switches. So while devices in different VLANs can communicate without a router, now devices in the same VLAN across multiple switches can communicate with one another. So a LAN spans multiple connected switches unless there is a router between switches. So a VLAN needs extra data to span switches. So in other words, a VLAN can actually be on multiple switches at once. And the way we do this is we have VLAN IDs or VLAN tagging. So basically, frames are tagged with a header containing the VLAN ID so that the recipient switch knows which VLAN the frame is for. So if you look at the picture here, we have the first VLAN. We have a device in the first VLAN sending an Ethernet frame. So this switch, before it sends the data out, it actually attaches a VLAN ID, so a VLAN 1, and sends it through the trunk to the other switch, which then examines the frame, sees that it's from my VLAN 1, and then sends it to the appropriate destination device. Now, you notice I said trunking. So multi-switch VLANs require VLAN trunking. So basically, trunking helps. Basically, what trunking does is allow multiple VLANs to, VLANs to. Well, excuse me. Trunking basically does the tagging. So that's why we set up VLAN trunking, is because the trunking is what creates the tags and allows the switches to allows multiple VLANs to coexist on multiple switches. Now, there's an important point you need to know is the native VLAN. So the 802.1q protocol, which is a trunking protocol, supports one native VLAN per trunk. So native VLAN is typically native VLAN 1 by default. So an interesting point is that native VLAN tags are not framed. I noticed some of you got that wrong in the first test. Keep this in your mind. Native VLAN frames are never tagged. So if it's the native VLAN, the switch does not put a tag. It doesn't add any data at all. It just sends the frame as it is. So native VLANs are important to help support switches that do not understand VLAN tagging. I'll pause for a minute here. I know I apologize for rambling a bit in this study session, but is there any questions anybody has, or am I rambling too much or anything?
No, you're doing great.
Thank you. I appreciate that. That's good to know. So let's talk about bringing up trunks. So basically, you remember administrative and operational modes. So basically, those determine basically, or I should say the administrative mode determines whether a two ports that are set to trunk will actually trunk. So there's three different statuses actually 4 different statuses you can set. One is access mode. Now you've noticed we've set certain access points or access ports throughout this class. So access ports do not trunk at all, never. They are never used for trunking. They're basically if you don't want to trunk the port at all, you make it an access port. So we do that for switch ports that connect to computers. So when you set access mode on one port, it doesn't matter what you set on the other port. If you set anything else, it'll just be access mode. Now, if you set access mode on one port and trunking mode on another, you actually cause a problem. This can actually cause errors on the switches. You never want to do this. You never want to put trunking mode on one switch port. You never want to put access in the other. This causes a problem. I recolored this table to make it a little clear from last time, but yeah, this used to be like a grayed out thing. This is The NA means nothing, it won't be a mode, it'll just be an error. You don't want to ever do this. The second mode is dynamic auto. So basically, this port will by default act as an access port, but if the other port does want to trunk, it's set to want to actively try to trunk, this port will become a trunking port. So you can see here, dynamic auto on one side and access on the other will cause the trunk to just be in access mode. It'll cause both ports to be in access mode. Two dynamic autos will cause the port will basically act as an access port, no trunking whatsoever. However, a port explicitly set to trunking mode and one set to dynamic auto will cause trunking to occur. The same with dynamic desirable. So basically, dynamic desirable is a port that's set to want to trunk. It's trying to actively find trunking connections or trunking negotiation. It's looking to work out some trunking configurations. Now, dynamic desirable in access mode will not result in trunking. So this is basically the safer way to have an access port alongside a dynamic desirable set port. I don't know why you would ever do that, but basically this won't error out. These two settings will not error out. These will. That's the major difference if anybody had any questions. But yeah, and dynamic desirable basically will basically cause both ports to be put in trunking mode. They will operationally trunk with any other setting other than access mode. So before I leave this table, I will say the black squares represent admin mode. Everything else in here is operational mode. I apologize for not clarifying that earlier. So let's discuss reviewing or looking at VLANs and trunks, like when you're troubleshooting, for example. So when you're looking at VLANs for like problems and stuff, you want to confirm the ports that are configured to the VLAN. Like you want to make sure the proper ports are configured to a VLAN. So like when you're working in a lab, like one of your lab assignments, and you note that one of the ports that should be in a certain VLAN is not, this is something you want to look out for. You want to make sure all the ports that are supposed to be in a VLAN are actually in a VLAN. You also want to make sure the VLAN actually exists, and you want to make sure it's not down or disabled. Here's some good troubleshooting commands for all this stuff. You can use show VLAN brief, show interface status, and show the MAC address table. You can look at the MAC address table, see if any communications are occurring. Ping obviously shows that too, but interface status is also helpful for details on the port. But show VLAN brief is the most important command in this case. So trunking, when you're reviewing your trunking, looking for problems, or trying to solve problems, you want to make sure you look out for mismatched trunking operational states. So basically, this would happen like when your administrative modes are not correct. So for example, if you're troubleshooting and you find that one port is access mode and the other is whatever else, I mean, you got a problem. So that is a problem right there. So if you have both ports are dynamic auto, they aren't going to trunk. Those are the kind of things you want to look out for when you see operational mode of not trunking or access. So you want to also look out for mismatched encapsulation modes. You want to always use 802.1q. At least in this course, 802.1q is what you always want to use. You also want to check allowed VLAN lists. Basically, trunks, you need to set, you can actually ban certain VLANs from traveling across the trunk. You want to make sure that there aren't any ports that are incorrectly banned. You want to also check out the mismatch. You want to check out for mismatched native VLANs. These can cause problems, by the way. You always want to make sure it's whatever else the other one is. You want to make sure they're the same. In this class, it's almost always going to be one. VLAN 1 is going to be the native port. And finally, here are some helpful troubleshooting commands. So show interface trunk, and those show interface, also type num switch port. So basically, this is the interface name, and then show interface switch port. So here's some tips for troubleshooting switch interface status and statistics. So show interface description is good for looking at the line protocol status, like looking for down or admin down /down. Show interface status can also show basically shows the status codes. They're basically the same as this. Honestly, I think these are a little easier to understand personally, like finding admin down/down. If you want to find manually shut down ports, show interface description is what you want. So also show interface type num can also provide deeper details or some more details like speed duplex and other interface statistics. We don't really bother with those in this class, but that's something to keep in mind like when you're out in the real world. So here are all the interface status codes. You may need to memorize these for the exam, just to help you out here. They're also good for troubleshooting. So admin down/down is basically an interface. Basically, you see that when an interface is manually shut down. You've probably noticed that by now, but when you look up, let me see the command here. So show interface status, instead of seeing admin down/down, you actually see the word disabled. That means the same thing. So down/down, line protocol status down/down, basically means there's like a physical problem with the cable. So basically like there's no cable configured, or there's a bad or wrong cable, or the other end of the cable is down. So maybe like so if you see this from like switch 1, you see down/down, there's a possibility in switch 2, the same port is shut down, manually shut down. So the interface status code that equates to these two codes is not connect. Now up/down, you don't expect to see that on the switch. That's more something you would expect to see on a router. We don't discuss that in this course. That's discussed in CIT 447 for troubleshooting routers, but yeah, this is not going to be something you're going to see on a switch. So down, however, down or error disabled, when you see the error disabled word or phrase, it means port security has disabled the interface. In other words, there has been a security breach and the switch, for security reasons, has shut down the cable or the port. And finally, when you see up, connect, it means the interface is just fine. At least as far as checking interface settings, you should be fine. So port security, we don't work with that like in GNS, but there were questions on this in test 1. There could be some in the midterm too. So we don't really work with port security. Like you're probably not going to be questioned on this stuff. It's more going to be like this stuff here. So when you're trying to look for interfaces of what port security is enabled, you want to show port security. So when you want to determine whether a security violation is occurring, you want to use the show interface status command. So the following command, or the command here, show port security interface, and then you type the interface name, you can see a bunch of details on violating interfaces, or basically ports that an attacker tried to access, tried to access, but port security shut down the cable. So you can see like the port status, the violation mode, the last source address for like the hacker, and then the security violation count, like if the hacker tried multiple times or multiple hackers tried. So the thing of it is that when you use protect or restrict mode, it becomes more difficult to diagnose these violations, and you'll see why. So basically shutdown mode is the most restrictive. The biggest difference is that it actually disables the port. It's the only mode that will actually disable a port if a violation occurs, and therefore is the easiest one to notice. The problem is that it brings down network performance, and your boss might not be too happy about that. So it depends. Basically, in the real world, it depends on how serious about security the network administrator or the people that run the networks are. But the other modes do have their purposes. So protect mode basically just discards the offending traffic. You pretty much won't know if a violation is actually occurring. Protect mode, I don't have any real world experience personally, but as far as I can tell, I don't see why you would want to use protect mode. Restrict mode is probably a better one. It's a good in between. So not only discards the offending traffic, it actually lets you know about it. It actually sends you a network message. It also increments a violation counter. So you can it's a little easier to know if a violation is occurring. However, shutdown mode, it does all these things, but it also directly shuts down the cable. So very obvious. It provides a very obvious sign if violations are occurring, but it may make some people upset. So restrict mode might be the best one, or shut down, depending on the situation. So one thing you need to know here is when you're trying to recover a port from the error disabled status, all you need to do is issue the shutdown command and then issue the no shutdown command. So basically shut down, no shutdown. So that will bring the port back up. However, if the interface, if a violation happens again, it's going to go back to error disabled. However, you can actually automatically set ports to recover. We're not tested on that. If you want to review that in your own time, you can, but I don't believe you're going to be tested on that because, again, port security is not a big topic in this class, at least not in GNS. So, any questions so far before I discuss the new content? Yeah, I'll take that as a no. So, without further ado, we're now going to go over the new content for this exam. I will say this, that you'll be seeing these slides again later because test 2 is specifically going to be focusing on routing. So that's just to keep in mind, but this is kind of like this is a good way to get familiar with this content. But yeah, you're going to be tested on it alongside all the other stuff we just went over. So I know it's a lot of stuff, but I don't think the exam will be too long. It's currently set at 30 questions, but that is the old version. We'll see how many questions you get later, but I think the exam will be done by tonight. We'll have to see. But anyway, if anybody wants to meet with me about the exam after or tomorrow before you take the test, I can oblige to that. But well, I can't do it in the morning though because I'm gonna have a meeting. But anyway, without further ado, let's discuss routes. So let's discuss some general information on routers and routes. So there's 3 sources of routes. There's connected routes, static routes, and then routes created by routing protocols. So routers will match the best route when trying to determine which route to send a packet through. Now, what this means, what you really need to memorize here is it matches the route with the longest prefix. So that's a fact you really need to memorize for the exam and also test 2. So before I continue, let me quiz you all. How are connected routes created? I wanted to check. Can anybody hear me? I just wanted to make
Yeah.
sure. Oh,
Connected
sorry.
routes,
Yes, ma'am.
aren't they created when you configure an IP address and you have to configure an IP address on an interface of a router, and it has to be connected to the interface of another router, or I think a switch that has also been configured with an IP address. And maybe you have to use the no shutdown command on them.
Very good. So the 2 answers that you want to keep in mind are the main requirements for connected routes are configure an IP address on an interface and doing the no shutdown command. So that is the basics of having connected route. That should be similar to one of your quiz questions. It could be something that appears in the exam. So who wants to explain how static routes are created? You don't need to provide the specifics, but how are static routes configured?
Static routes are configured with the IP route command.
Very good. Yes. Configure manually with the IP route command. Very good. So finally, routing protocols, I don't believe you've worked with those yet, if I'm correct. I think that'll be after the midterm. But routing protocols basically create routes automatically, believe it or not, but you have to configure the routing protocols. You'll actually be working with one pretty soon. It's called OSPF. You'll be testing on that a little bit in the test 2, not the midterm. You don't need to worry about routing protocols in the midterm, at least as far as I know. But yeah, that's basically a third source of routes. So the router will use the best route. Just make sure you memorize this. It matches the route with the longest prefix. So connected routes. So routes to networks where the router has an interface. Should have fixed that. I'm sorry. So basically the router determines these routes from the interface IP address and subnet. It's listed in the routing table with the prefix C. So to configure the connected routes, you add an IP address to an interface and issue the no shutdown command to bring the interface up. As you all said, and that was very good. So static routes. So these routes are entered by the network administrator. So they're listed in the routing table with the S prefix. They're easy to understand network behavior. Might be some disagreements on that, but they avoid problems with routing protocols. However, they require extensive planning for large networks. They do not adapt well to changing networks and do not scale. So basically, static routes don't really account for network growth. They're very difficult to configure. So like you've noticed in your troubleshooting lab, like when you change the subnet, you have to change a whole bunch of stuff. You have to change the static route and stuff. Like granted, you have to do it to the OSP route. You have to do that with routing protocols like OSPF, but it's overall a little more difficult. When you make changes to a network you have to change quite a bit you may have to change a lot of static routes. OSPF honestly has the ability to update changes, although you may need to change the configurations. So static routes are created by the IP route command. So the way this command works is that you type the destination network, that network subnet mask, and then you include the next hop IP address or outgoing interface. So in other words, say you have one router on the left and one router on the right. So if you're configuring the left router, this address right here is the very far right of the router to your right, if that makes sense. This is its subnet mask. And then this is the IP address on the router on the right that is adjacent to the router you're configuring. Does anybody have any questions on that? Does that make sense?
Yeah, that makes sense.
Good. So this command here is basically the same thing. It's just the destination network. It's subnet ID, I'm sorry, subnet mask. But main difference here is this. So this port here is connected to the router you're configuring. It basically is the port that is going in the direction of this network. So if you have two routers, this is the port that connects directly to the second router. So very important for the exam. I'll give you a little hint. You will be quizzed on this in one of my questions. So you want to discuss default static routes. You really want to understand this. So what happens if no route matches an IP address? So the packet is typically discarded by a router unless there is a default route. So the default route matches all destination addresses. It's listed with the S prefix with an asterisk in the routing table. The default route is always two sets of 4 zeros, followed by the IP address or the next top IP address. So in your troubleshooting lab, you actually had to configure a default route. So the reason why your pings weren't working is that the router knew how to send your ping request to the destination IP address, But when the PC tried to reply, the router didn't know where that source the source subnet that request came from. So that's where static routes, or excuse me, default static routes come in. So basically, it's a catch-all. Basically, if the router can't figure out where it goes, it sends it to another router that hopefully knows where it goes. That's the point of static or default routes when you use static routes. Should be noted that you really can't combine static routes with routing protocols on the same router. You really can't do that. It causes a lot of problems. They don't really work together. So you only want to have one in the same network in general. You only want to have one in the same network, let alone the same router. So here's a view of the routing table. So you can see it gives you a bunch of codes that refer to all the routes on the table. So in this route, you have two connected routes, and then you have a default route. So a little question here is, what does a router compare in its routing table to the destination address of an incoming packet? So it actually compares, to figure out where it's going, it uses the subnet ID and subnet mask. It calculates the subnet ID and mask, compares it to its routing table, and then sends that frame out whatever route it's intended to go through, assuming the router is configured correctly. This is the normal boot sequence of a router. All you really need to know about this is that this is basically the steps the router takes to try to boot. So the router tries to boot each boot system command in the starter config file in order until one works. If none of these commands work, it loads the first iOS image found in flash memory. So this is basically just some hardware information you might be quizzed on. You won't be quizzed on too hard. Configuration registry, just memorize 00-003. Memorize this hex. Actually, these are what you might want to memorize here, like 3 zeros and 2 to 3 zeros and F. That is the normal boot sequence. These are the normal boot sequence codes. That, I think, will be the thing you want to memorize for the exam. So here's a few troubleshooting tips. So this is important. You will have a troubleshooting question in the exam. So one thing you might want to keep in mind, actually, we technically have two troubleshooting questions in the exam. But when you think about troubleshooting, you want to have a certain process. So for example, you want to be able to explain why traffic does not flow. That requires a knowledge of routing logic, routing tables, also switching logic, and the ARP process. So you basically want to know how routing tables affect how networks do or do not work. You want to keep in mind how switches learn MAC address frames and stuff like that, and how that can affect traffic. You also want to keep in mind the ARP process, also the ping process too. Those can help you understand how traffic flows, and can help you pinpoint where or why traffic does not flow at a certain point. You also want to have a general knowledge of the OSI layers that are involved in network transportation. So there's layer 1, which is the physical layer, that's interfaces and cables. Layer 2 is MAC addresses and frames, that's switching. So something to add here is IP addresses and packets. There's actually a difference. So packets are a layer 3 construct. Those are basically it's basically the data that it basically contains the data of a communication, like a ping request. In layer 3, that's a packet. So that's in routing. Think of it as though you have to think from traffic. Basically, network traffic is basically created from the bottom up, if you know what I mean, or depending on your perspective. So in this list is bottom up. So first, the packet, a computer forms a packet. It then puts that packet in a frame, and then that frame travels across the cables and through the interfaces of the devices. So that's basically how networking traffic works. Some additional tips are each active interface on a router is a different subnet, and routers are used to allow traffic between different subnets. That's the purpose of routers. So before I continue, is there any questions you have concerning what I've talked about? I'll take that as a no. So there's some additional show commands that you'll need to be aware of for routing. One of them I just mentioned before is show IP interface brief. So compared to the other show commands, this one actually shows you the IP addresses. It also shows the line protocol status and names the interface. So it's if you want to look at IP addresses, this is arguably the best place to look, especially if you want an overview look. Now, show IP route here shows the routing table. It's pretty simple. So as I said, it shows the codes at the top, and then shows you the routes that are configured on a switch. So right here, you see OSPF routes configured and connected routes. One other command here, show interfaces or show interface name. So this command actually provides detailed information on interfaces. What's significant about this command for routing, though, is that it shows the subnet mask. If you look here, internet address it gives the IP address, and then the subnet mask inside are notation. So if you're looking for subnet mask being configured correctly, this is the command you need. It's different from all the other show commands. So if you see here, show IP interface brief, you don't see any subnet masks. You don't see any indication of what subnet these addresses are in. But here you do. So that's something to keep in mind, especially in CIT 447. Okay, before we begin, this is the final stretch for the review session. I'll let you know that the remaining slides all concern subnetting, and all these slides are on Canvas. I edited them a tiny bit to make them a tiny bit more clear. But let me ask you all quickly, how are you all on subnetting? I'm quite curious.
I've been getting good grades on the subnetting quizzes.
Very good. So basically, I will clarify. This does use the magic number method. What I'm discussing uses the magic number method. If you're fine with the binary, you can kind of ignore what I'm talking about if you want, for the most part. But if you're interested in learning the magic number method, honestly, this is a really good time to start. I would say that it's from my experience, it's faster unless you're really good with binary. This is an overall faster method. So basically, the magic number method helps you find the subnet ID and broadcast address. If you don't like binary math or want a quicker time or a quicker method to save time in exams, the magic number method is really good. When I was taking this course, I can answer certain subnetting questions in less than a few seconds, probably between 6 and 10, depending on the question, believe it or not. It had to be a pretty easy one, granted, but yeah. At most, a subnetting question with the magic number method could take about 15 seconds if you're good with it. It was actually taught by Professor Cunningham. I'm very thankful he taught me because it helped me actually learn something. I was never incredibly good with the binary. I have a basic understanding of it, but I kind of find it a little cumbersome. I find it kind of difficult to visualize in my mind. So basically, instead of using binary math with, binary method, as the name implies, magic number method uses decimal math. So basically, it's mostly multiplication and addition, or simple multiplication, and then for the broadcast address, it's a little addition and subtraction. So basically, magic number method is good because it actually has patterns that can help you determine which octets remain the same and which ones need to be calculated. And in general, it's a bunch of mathematical patterns. And it's a bunch of mathematical patterns. I'll show a table soon, but you'll see what I mean when I discuss it. So there's a total of 6 steps used to find the subnet ID and broadcast address. Excuse me. So when you're finding the broadcast address, you'll need to follow all 6 steps, but when you're finding the subnet ID, you only need to go up to step 4. So basically, the magic number method starts with you examining the CIDR prefix, the CIDR prefix, formatting the normal octets, and then finding the interesting one. So we can actually start that right here. I list the steps in these examples, but anyway, we're going to go through a practice problem to learn the magic number method. And this problem is giving us the subnet ID of 10.77.55.3/13. I'm sorry. So our first step is to examine the CITER prefix, format the normal octets, and find the interesting octet. So the first step is to find the subnet mask's dotted decimal notation. Now you can do that by memory. There's a specific pattern that that can help you learn this. That'll be in a table I'll show in a minute after we get through these examples. But so /13 equates to 255.248.0.0. So if you see in the table here, when we're working with a magic number method, you take the subnets in the mask, or the octets in the mask that have 255. You basically carry over that part of the IP address into the subnet ID. They're going to be the same, in other words. That's because 255 is all network bits. Wherever you see 255, that's network bits. And the network bits remain the same between the IP address and the subnet ID. Now, zeros are basically your host bits. They carry over into, these octets that are completely host bits carry over as zeros into the subnet ID. Now, your interesting octet where there's an overlap of network bits and subnet bits, there we do not know this number. We have no idea what this number is right now. The 77 is not going to be carried over, most likely will not. And we just put a question mark here. Now, you don't need to always write it down this way. If you're memorized, you could do this on your head. But if you want to, you can write this all down like this to figure out which octet you're solving for. So you may ask yourself, how do we find this octet, the number that belongs in this octet? So the way we do it is find the magic number, hence the name, magic number method. So for this step, we use a special formula that employs simple subtraction to find what is known as the magic number. To find this number, take the dot decimal notation value of the subnet mask's interesting octet and subtract it from the number 256. So it's not 255, it's just 256. So 256 minus 248, as you see in the interesting octet here, equals 8. 8 is our interesting octet. So what do we do with this interesting octet, or this number? So what we do with it is find the multiple of it that is closest to or equals the number or the interesting octet in the IP address without exceeding that value. So if you look back at the table, our address is 77. Excuse me, our interesting octet is 77. So our goal is to find a multiple of 8 that is closest to or equals 77. But we want to make sure we do not exceed it. So if you see here, you have 8 times 8 is 64. That number is too small because 8 times 9 is much closer, it's 72. However, 8 times 10 is 80. It's bigger than the interesting octet. We can't have a number that's larger. We can have a number that's equal to it, but not larger. So therefore, 72 is the correct answer. So if we go back to our table, the second octet is the interesting one. So with our calculation from step 3, our subnet ID is 10.72.0.0. Now the reason why our subnet ID interesting octet cannot be larger than the original number is that you got to think of this as a range. So we're finding the beginning of the range of addresses in the subnet. Think of it is that the subnet ID is the very first address. The reason it's called subnet ID, it basically represents the subnet. It's the number that represents it. You can't use this number on a router or switch or anything for that matter, but it basically represents the very beginning of the subnet. It represents it. So we're trying to find the number that is that is in the very beginning of the subnet. So in this case, it's 72. On the other hand, the broadcast address is the very last address in a subnet. So we basically go through the same steps again, carrying over the 10 carrying over the number wherever a 255 is. The non-255 or non-zero number in the subnet mask is our interesting octet. But in the subnet mask, if there's a 0, that number becomes a 255 in our broadcast address. So these zeros here in the subnet mask become broadcast addresses in these octets. So once again, we have the same interesting octet. We also have the same magic number. We do the same thing. We just take the 248, subtract it from 256. We have the same magic number. we do the same process again. We're basically starting by solving the subnet ID. So we find that it's 10.72.0.0. So to find the broadcast address now, what we do is we take this number here. We take this number that we solved for, the subnet ID number, interesting octet. Excuse me, the subnet ID interesting octet number. We add the magic number to it once, and then we subtract 1. So that becomes 79. So the broadcast address is 10.79.255.255. The reason we subtract 1 is that we're finding the very last address in the range. So most subnet IDs are going to start with 0. So the broadcast address can't be 78.0 because that's the next subnet ID with this mask, with the mask of /13. That's why we subtract from 1 the interesting octet and add 255s at the very end, or the other octets. Does anybody have any questions on this method for solving for subnet IDs of broadcast addresses? Is everybody pretty familiar with this?
I wasn't before, but it's making sense now.
Okay. So what I said then helped you?
Yes.
Good. That's very good to know. So here's a magic number conversion chart. And in general, for subnetting, this is a very helpful chart. What you want to pay attention to here is the DDN. So I also list the binary for those that use it. And I have the CIT masks, and I also have the magic numbers. So basically, something you might want to memorize is the dot decimal notation that matches the CIT masks. Oh, sorry. Okay, there we go. So the dot decimal notation that matches the CIT mask, you want to memorize that. And then you want to memorize the magic number that matches these dot decimal notations and CIT masks. So basically, if you memorize the magic numbers, you don't even need to calculate for them if you can memorize them. The same is true for the dot decimal notations. If you memorize those, and you memorize which classes these subnet masks are in, you can do a lot of this through memorization without writing it down. That's actually how I did in this class when I took it. I got to a point where I memorized the magic number for every mask that was given. I memorized this all. It really helped. My method for memorization was actually taking scrap paper every day and multiple times, writing these numbers over and over again. I honestly highly recommend you do that. If you want to write down the binary for memorization, you can do that too. Whatever method works best for you. But writing practice helps tremendously in this course for subnetting. I cannot stress how much that helped me memorize it. Granted, I don't do that practice anymore. I really need to start doing it again. But when I did it, it helped me memorize it. I was able to answer subnetting questions in less than 10 seconds. I mean, you can too. If you have the time to practice and stuff, and you do practice, you can memorize this stuff and answer these questions really quickly. Now, I know I've been given a lot of questions about finding CIT masks for maximum subnet host questions. I don't know if this will appear in the exam. I kind of doubt it. But again, Rana didn't tell me about what's going to be on the exam, except it's going to be comprehensive. So just in case, we're going to be going over this because out of anything subnetting, I've received more questions for this than anything else. So basically, the goal of these questions is to find a mask that supports the maximum number of subnets or hosts in a given network. The thing of it is, what you're really trying to solve for is the number of the subnet masks that will support the minimum or required number of hosts and vice versa. So in other words, if you're asked to find the maximum number of subnets, that basically means you want to minimize how many host bits are in your subnet mask. Therefore, you want to try to find the mask that will best support that mask without wasting too many precious bits for subnets. So you're basically trying to find the smallest mask that supports the number of required hosts while leaving enough space to maximize subnet bits. I hope that makes sense, but That's basically the goal of these questions. So basically, the reason you would do this is that if you have, if you're designing a network and your administrator emphasizes having more like subnets or LANs over host count, then you want to find a mask that supports the maximum number of hosts. Now, however, if your network design doesn't have a lot of LANs, but has a lot of hosts in each LAN, you'll want to find a mask that'll support all those hosts, but also support the minimum number of subnets. That's where this application comes in. These questions are not here to annoy you. I know they're hard, but they do have a very important significance. So for these questions, there's 3 major steps. I'll go over them as we look at these slides, but basically, there's just 3 steps to these problems. It's not terribly hard once you get used to it. It takes a little time to get used to these, but once you master them, it would be very easy. So we have a problem. I'll give you an example problem. So our problem is to find the masks that each give the maximum subnet and host bits for the following requirements. So this question is a little bit different from what you see in Canvas. Basically, I'm asking for both masks. You typically aren't asked that in the questions, and at least as far as my short answer questions go, you won't be asked this. Rana could make something like this. I don't know, but this question I'm going to ask for both. So step 1 is to evaluate the values or examine the values you've been given. So for problems like this, you will be asked to find a mask that would maximize the number of subnets or maximize the number of hosts, as I just said. So let me explain this clearly. So if you need to maximize subnets, you need to find the required number of host bits using the number of needed hosts in the example. So basically, if you're asked to maximize subnets, use this number, use 6 hosts. If you're asked to maximize hosts, take this number, subnet number. You need to take the subnet number. So step 2 is to find the required subnet or host bits by using powers of 2. So part 1, so for the first thing we're going to do is find the, we're going to find the number we're going to find the needed number of host bits. So there's a specific formula we use for this. It's hosts equals 2 to the power of h minus 2, where h equals host bits. Basically, we're solving for h. We're looking for powers of 2, subtracting 2 from that power, or whatever. Yeah, we're subtracting 2 from that power of 2. Does anybody know why we do this?
That's because we're withholding 2 addresses, one for the network ID, the other for the broadcast address.
Yes. I just noted my headset was disconfigured, or it was actually unplugged. Did everybody hear what I said back there? I just wanted to know, did I cut out at all when I was talking about the example or maximum subnets and hosts? I noticed my headset was unplugged for a second there.
No, the audio just sounded different though.
Okay, just as long as I was recorded, that's all that matters. I apologize for that. But anyway, yeah, so basically the reason why we subtract 2, we don't want to count the subnet ID and broadcast address in our calculation, because we can't configure those. Those are unusable. You can't configure those to a host computer or a subnet or a switch or router or anything. They're basically representative. So with this formula, we need to find the closest number that equals or exceeds the number of needed hosts. So the goal is to find a number that equals or exceeds the number of needed hosts, but we want to find the smallest number that meets this need. So we can maximize subnets. So that's the point of this calculation. We don't want to find something smaller. If we find something smaller, then when our administrators go to build a network design, they won't be able to support all the hosts that they need to, because the number of supported hosts is smaller than the number of required hosts. Therefore, that's why we need to find the number that equals or exceeds the number of needed hosts. And actually, typically in real world situations, you actually exceed it by a little bit, like calculating growth, network growth, because networks actually do grow sometimes. You want to be able to support network growth. But anyway, for these questions, we're just concerned with finding a number that equals or exceeds it. That is as close to the needed number of hosts as possible. So for example, we need 6 hosts. So we make this formula. 6 is less than or equal to 2 to the power of h minus 2. So basically what you do is plug in multiple numbers. You plug in different numbers here. So like you can try 1 or 2 or 3. Think of it as 3 is the answer because 2 to the power of 3 equals 8. Subtract 2 from it is 6. And this just meets our needed host bits. Now, on the other hand, for maximizing host bits, we need to find the number of needed subnet bits. So we don't subtract from 2 here. We just find the power of 2. So that's pretty simple there. So again, we're finding the closest number that either equals or exceeds the number of needed subnets. So for our example, we have the number 15. So our formula is 15 is less than or equal to 2 to the power of s. So we find that 16 equals 2 to the power of 4 equals 16, where 4 is the number of required hosts or subnet bits. So you can see 16 is just a bit bigger than 15. If we use 2 to the 5th power, that would be 32 if I'm correct, and that would not work. So 16 is the closest number to 15 while still meeting its need, the needed number of subnet bits. So the final step is to calculate the required subnet mask in CIT notation using the power of 2 you got from step 2. This is something I've gotten a lot of questions about. Please make sure whenever you do these questions, always include the slash in your answer. You always want to include the slash in your answer, because that's how CIT notation is written. But anyway, to finish up with finding the mask that provides the maximum of subnets, we have yet another formula, which is 32 minus h, where h equals required host bits. So if you look back here, we agreed that h was 3. So we just simply subtract 3 from 32, and we get 29. So that would be the answer to this question. It'd be slash 29. Now, finding the mask for the maximum hosts to maximize hosts is a little bit more difficult. We use another formula, n plus s, where n equals network bits and s equals required subnet bits. So we agreed back here that s equaled 4. The thing of it is that n takes a little figuring out. So to find the network bits, n equals network bits, to find this number, we need to examine the first octet of the IP address and determine which class it resides in. Because 192.168.44.0 resides in class C, the number of network bits is 24. So I actually updated this slide to include the ranges. So class A goes from 1 to 127, and that will equal 8, n will equal 8 here. Class B is 128 to 191, and that n will equal 16. So for class C, 192 to 223 is the range, and that will equal 24, as in the case of this question. So all we need to do after figuring that out is simply add the network bits to the required subnet bits. So for our problem, 24 plus 4 equals 28. Therefore, our answer is 28. And for reference, my final slide in this thing, I add for reference the powers of 2. Something I also recommend you practice writing down. You want to memorize the powers of 2, and which number, like the exponent, you want to memorize which exponent matches the answer, or whatever the power of 2 is. So for example, you have 2 to the power of 2, you want to be able to memorize that that's 4. And you want to memorize that 2 to the power of 5 equals 32, and so on and so on. This is very important for the exams and stuff. So that's basically all there is to my study session. Before I end, are there any questions anybody would like to ask? Excuse me. Hey Ben and Connor, I know you two got here after I started, but I wanted to share some details with you. I think I'll stop recording now. I think we're good now.